Hello, welcome to another SteelHead Know-How session brought to you by the Riverbed Support YouTube channel. My name is Edson Gonçalves and I am an escalation engineer at Riverbed. In today's know-how, we will review some MTU setting considerations with the SteelHead. In most networks today, the MTU is usually unchanged and is set to a standard of 1500, unless you are dealing with jumbo frames. When a host sends a datagram that has a larger length than the maximum transmission unit, aka MTU, a router will usually perform what is known as fragmentation. This is when the datagram is broken up into smaller pieces so that the packets can pass through the link and they are later reassembled by the receiving host. This is something most people are unaware of when dealing with SteelHeads, which can cause issues if they're not prepared for the correct MTU settings across the network to account for larger payloads being sent across the network for optimized traffic. SteelHeads have the DF bit set to 1 for optimized traffic only. Pass-through traffic is not altered, and the DF bit stands for do not fragment. So when a router tries to fragment a packet with a DF bit set to 1, it can't, and it will drop the packet. It'll send an ICMP message with the destination unreachable, along with a code that indicates fragmentation is needed and the DF bit was set for the reason it was dropped. Symptoms can be that the connection establishes, but there's no data that passes through the SteelHead, or a connection is failing, or it runs very slowly. Now, the reason that it can run very slowly is because let's say that the packet that's making it through, like the SYN ACK, is very, very small, right? It's less than 1500. But the data, maybe some packets are 500, 600, but then one packet's 1600 gets dropped, right? And then the router has to drop it, and then the client knows it's dropped, so it tries to send it again. So you can have very small performance, right? You can have very slow performance because of that. Now, the KB article that was below basically is determining what is the MTU setting that you should have on your WAN link. The ping command is a very useful tool to determine MTU settings. It basically stimulates a payload that traverses through the network with a SteelHead sourcing the traffic on one of its interfaces. So the syntax would be ping-i with the local IP of the interface, -m for MTU discovery, and you can do -do-c, which would do the count, how many times you want to do it, and with the -s setting, you can put the MTU value that your network has, which would be most likely like 1500. Now, the goal of this is to keep testing this number. All right, if your MTU is 1500, maybe you can start at 1490 or 1480. Keep in mind, the TCP options from the SteelHead, and the ping has an additional header of 28 bytes. So for instance, in this test, we decided to pick 1440, and the device that's returning the frag needed when DF set, which is 10.10.1.1, is a router. Now that router is saying that the frag was needed and the DF bit was set because the MTU is set to 1467. Now I know what you're thinking, but we set the segment size to 1440. That should work. Well, since the ping option adds a 28 byte overhead, the actual packet length, the payload that's going through that router, is 1468. Since 1468 is larger than the MTU setting, the router will have to drop it because the DF bit was set to 1. So basically, this is the type of test. You keep on checking the number, work your way down until you get just a ping without the frag needed and DF set. So you'll get the ICMP sequence with the 0 saying that it was reachable, and once you find that number, that's what we recommend that you put the MTU setting to. Now, I've had many cases over my career working these cases, and I'm going to show you an example of a customer that had an issue with an interceptor. Now, the customer deployment was a client-side interceptor with 2 SteelHeads in the cluster. Now, the issue that was reported was that the user could not load an HTTP web page that was going through the Riverbed. All right, going through the IC, gets redirected to the Riverbeds, get optimized, and it goes on its way to the other server, destination data center. Now, the problem was that he wasn't able to download a file using HTTP. Basically, what would happen was when he tried to download that file, the browser would just spin. The customer was using jumbo frames throughout his network, so he had all of his MTU settings set to 9216. Now, the interesting thing was that when you looked at the SteelHead for that connection, right, you can see over here, if you follow the mouse here, that this little symbol means that it is an optimized and it's an established connection, which means that the TCP SYN, ACK, and ACK happened, and all outer channels were established. It's an optimized connection. It's just that, obviously I'm blurring out the IP, destination, and source, but if you look over here, the LAN and WAN, as I described earlier, is 0. But it's an optimized connection, but no data is passing through. Now, as I go over the resolution here, we did many TCP captures, and we showed that from the IC, from the client-side IC, there was a 2,000 byte packet that was missing when it was leaving the interceptor. We would see it at the client-side interceptor, but we wouldn't see it on the server-side interceptor, where it was supposed to receive it. Basically, after much testing, it turned out that the router on the client side, that interface that the interceptor was sending that 2,000 byte packet, he had forgotten, the customer, to set that MTU to 9216. It was actually still set to 1500, which is why we weren't able to see that 2,000 byte packet, because the optimized connection had a DF bit set to 1 and it was being dropped. Anything lower, obviously, like the TCP SYN, ACK would go through, which is why the connection was established. Now, this is just an example of something, and obviously once the customer changed that physical interface MTU to 9216, he had no issues. He was able to file transfer, download those HTTP web pages, and everything was nice and gravy. Once you have gone through the MTU testing using the ping commands I have shown you, you will eventually have to change the MTU settings. I'm going to show you how to do that quickly on a SteelHead appliance via an SSH session. So I've logged into one of our appliances here, and you can quickly go over the configuration of the interface that you're interested in by running this command. As you can see, it returns the MTU value, which is now set to 1440. And let's say 1440 was too big, you need to lower it down to, let's say, 30 bytes. Let's say you need to make it 1410. Now, the IP address here is a private IP address in the lab, so I wouldn't worry too much about that. This is how you would change it. You go into configuration mode, you go into the interface of interest, and it's pretty simple. You just pick the MTU value, and once you hit enter, the change takes immediately. And like I said, you can verify it. By running this command again, and the new MTU value is now 1410. Now via the web UI, it's even easier to make this configuration change. If you navigate to networking in-path interfaces and you open up the pull down tab for the in-path 00, if you navigate down to the bottom where it says MTU, you literally would just select the MTU value you wish, for instance 1410. You would hit the little blue apply button at the bottom, and the change would take effect immediately. That's how easy it is and how simple it is to do it via the web UI, which is how most customers would be making this change. It's just something for you to consider, and keep in mind those MTU settings with the DF bit set to 1. Thank you for watching. My name is Edson Gonzalez, and you have a great day.